Hello and welcome to yet another episode where we're going to be looking at how do we prove the sum of an arithmetic series, okay? Now, sometimes this question is examinable, okay? They can tell you to prove that the Sn is equal to n over 2 into brackets 2a plus n minus 1 into d, okay? So definitely we know that this is an arithmetic kind of progression, okay? So we know that for any arithmetic sequence or series, we know that the first term will always be given as a. And then the second term will be a plus d. And then the third term will be a plus 2d, and so on and so forth, okay? Up until the last term, okay? Which last term is known as the nth term. So what I'm going to do, I'm going to let the last term, okay? Let the last term be, let's use letter L, okay? So that the sum of our progression, so we're gonna use Sn for the sum. So I'll say that sum of the first n terms will be a plus d plus, then I'll have a plus the 2d. And then plus, I can skip whatever numbers are in between there and probably write the last three terms, okay? But now we said that the last term will be L, which means the second last term will be less d from the L. And then the third last term will be less twice d. So I'll have L minus 2d plus L minus d. And then lastly, I'll have the L. So if I group this nicely, this is just term 1. This is going to be like term 2. This is going to be term 3. This is the third last. This is the second last. And then that is the last term, okay? Then I'll go on and rewrite this equation, okay? But in a reverse format. So which means I can start with the last term. So I'll have L plus, now we say that is L minus d plus, this is L minus 2d. Is that true? Yes. Then plus, I can have whatever terms are there, and then I'll have my a plus 2d, and then my a plus d, and then I'll have my a as the last term. Then I have my two equations, okay? So equation 1 and then equation number 2. Then all I'll have to do is just plus these two equations and see what I'll get. All right, so on the left-hand side, I have Sn and Sn. I'll get twice of the Sn's, okay? And then this and that, I'll have A plus L. And then when I look at the second term and this one, the D's will cancel. I'll still have A plus L, okay? Same story here with the third term. I'll have A plus L. And the story continues. I'm going to have just A plus L everywhere. Now, since I'm talking about a finite series whereby there's an end, there's a limit somewhere, we're talking about a certain number of terms, which we don't know. So I'm just going to call that n, okay? So I'll have 2 Sn should be equivalent to n into A plus L. I mean, everything is A plus L, A plus L. Now, if I'm talking about 10 terms, it's as good as me multiplying 10 by the A plus L, and then I'll have my sum, okay? And then I'll divide both sides by 2. So my Sn is going to be n over 2, open brackets, A plus L. But we know that the last term, which is the nth term of an arithmetic, is given as A plus n minus 1 into d. So I'm going to replace L with this whole thing, okay? Then I'll have my Sn being equivalent to n over 2 into A plus, now we have that A, and then plus n minus 1 into d. We close the brackets. Then let's just collect the like terms and simplify within that bracket. So our Sn becomes n over 2 into 2A plus n minus 1 into d. So that is how we prove the sum of an arithmetic series. All right, so that is that. There we go. Thank you.